In an earlier video, I mentioned that whenever you factor, if you want to make sure your answer is correct, you have to ask yourself these three: factor correctly, and did I factor completely? In this video, I want to focus on number 3, the did I factor completely, because it's a common source of mistakes. Remember, what did I factor completely means is, once I factored, could I factor more? In kind of the same way as if I said that 30 equals 10 times 3. Well, I factored, but is it complete? And of course it's not, because 10 is 2 times 5. So really I should say 5 times 2 times 3 is the complete factorization. Same thing with variable expressions. Let's take a look at some examples of this. So we have 12x squared minus 75. Anytime we have a factoring problem, we always start with the GCF. And in this case, we can notice that 12 and 75 are both divisible by 3. So we could factor out a 3, leaving a 4x squared minus 25, right? 75 divided by 3 is 25, and 12 divided by 3 is 4. And then the question is, did we factor completely? Is there more that we can do? And while it's true there's no GCF inside of the parentheses, it actually turns out that 4x squared and 25 are both perfect squares. So we can leave that 3 alone, but 4x squared minus 25, because of the difference of squares formula, will actually factor into 2x plus 5 and 2x minus 5. And so this is our final answer: 3 times 2x plus 5 times 2x minus 5. Let's take a look at example 14. 4w times 5w minus 2 plus 8 times 5w minus 2. Here we can readily see the 5w minus 2 as a common factor. When we factor it out, we're left with a 4w plus 8. And again, we factored, but did we factor completely? Well, when we look at 5w minus 2, there's nothing to do, right? There's no common factor. They're not perfect squares, of course. But when we look at 4w plus 8, we actually see that we could factor a 4 out of each term. They're both divisible by 4. So we can leave the 5w minus 2 alone, and we can factor out a 4 out of the 4w plus 8, leaving us a w plus 2. At this point, you technically have your final answer, but because the 5w minus 2, 4, and w plus 2 are all numbers we multiply, and it doesn't really matter what order we write numbers that we multiply. We usually, if there's a number, we write it out front. It makes it look prettier. So we would write our answer as 4 times 5w minus 2 times w plus 2. This is how we would normally write the answer. Let's take a look at one more example. Example 15. 8x cubed minus 12x squared minus 2x plus 3. There's no common factor. Not every term has an x, and certainly 2, 3, 12, and 8 don't have a common factor. But maybe we can do this by grouping. And indeed, the outer product is 24x cubed, which is the same as the inner product, 24x cubed. It looks like grouping is the way to go. We could factor out a 4x squared from the first 2 terms, leaving us a 2x minus 3. The 2x and 3 here don't have a common factor, but we should factor out a minus 1 to make the signs match what's in the first parenthesis, because negative divided by negative is positive, and positive divided by negative is negative. So that will make the 2x minus 3 match. And now we can factor out 2x minus 3. leaving us 4x squared minus 1. At this stage, you could be well satisfied with yourself, but you should always ask, am I finished? And again, looking at 2x minus 3, nothing we can do. They're not perfect squares. There's no common factor. When we look at 4x squared minus 1, there's no common factor, but wait, 4x squared is a perfect square, and so is a 1. So we could again use the difference of squares on the 4x squared minus 1. We will leave the 2x minus 3 as it is, but 4x squared minus 1 is, of course, 2x plus 1 times 2x minus 1 with the difference of squares formula. Hopefully, looking at these three examples, you have a little bit of a sense of what it means to factor completely, and that every time that you factor, you should be vigilant and consciously ask yourself, am I finished? Once we get a little bit more practice with factoring, hopefully this will be something you'll just automatically do. But for now, you may want to make a mental note to constantly ask yourself that question. So this is where we end this series of videos. You're now ready for your 11th assignment. Good luck.